Hello guys, welcome to Malik 034 channel. This is Malik Arjun. In this today's session, we will try to understand how the Exadata patching process works and what is the difference in the normal traditional patching and this Exadata patching, and how this bundle patching takes place, and what is Exadata QFSDP quarterly full stack download patch, and what are the Exadata components and how the patching method works in Exadata, like rolling, non-rolling, hybrid, and what are the different components we will patch in Exadata, and then what are the different tools we will make use for this Exadata patching. Everything we are going to cover in this session. So before I get started with the actual technical discussion, so if you are new to my channel, I request you to go back to YouTube and search for Malik034, and then please do subscribe. And if you like my videos, please like, share and comment. So if you missed my previous videos or previous sessions, always go back to YouTube and refer my previous videos or previous sessions. Let's get started with the today's session. Exadata components, like if you see my basic Exadata architecture, I already explained all the Exadata components in detail, but quickly I'm going to cover what all Exadata components Exadata box comes with. So this is my typical Exadata box. This Exadata box comes in a box in setup, and inside this box I can see DB nodes, I can say DB servers or compute servers, and cell nodes, storage servers or cell nodes, IB switches again, leaf switch and spine switch. I will have my IB switch, and there's a Cisco switch inside my Exadata box, and there's a KVM, keyboard, video and mouse, and there's a PDU, power distribution unit. So these are the typical the components comes along with my Exadata box. So and then these are the components the patching takes place in bundle patching or Exadata patching. Let's go to the next slide. So Oracle QFSDP patching. The QFSDP stands for quarterly full stack download patch. It means Oracle will release one patch ID, and inside that patch ID we can see all my DB patch, all my storage patch, all my IB switch patch, all my bundle patch, all my database patch. Everything will be bundled together in a one zip file. That is why they will call it as a QFSDP, quarterly full stack download patch. So for example, January patch, if I download, I if that is a single zip file, it contains all the patches. So that is why they will call it as a quarterly full stack download patch, bundled together in a single patch, right? Okay, the question comes, Oracle will patch on below component. Like the question is, what all component Oracle can patch, right? So Oracle can patch DB servers, Oracle can patch storage servers, Oracle can patch IB switches, and Oracle can patch BP, bundle patch we can call it in Exadata. So BP is nothing but our normal traditional PSU, whatever we call it as PSU, that is a BP here in Exadata, and database patch. So DB server, they will call it as a M patching. Normal traditionally in Linux server, we can call it as a M update, kernel patching, M patching, right? So and storage server cell patching is nothing but again this is the M patching, because storage server also has a Oracle Linux OEL. So that is also again uh, normal traditionally call it as a M patching. But in Exadata we can call it as a M patching for DB node, and storage server we can call it as a cell patching, and for the IB switch we can call it as a IB switch patching, and for the O patch or bundle patch we can call it as a bundle patching. Opatch we can call it as a bundle patching. So Opatch, the PSU patching and grid home, and PSU patching and DB home we can call it as a bundle patching. And the database patching is nothing but DB patching. DB patching is the like cat bundle or data patch. Okay, so coming to the tools, like M patching will be done using dbnodeupdate.sh. Cell patching can be done using patch manager, and IB switch patching can be done using patch manager again. The bundle patching can be done using Opatch, and this DB patching, database patching, can be done using cat bundle or data patch. So these are the typically the components Oracle will patch on whenever you request any patching. So how frequently they will patch? So again it depends upon quarterly patching or half yearly patching or yearly patching, or as per the customer wish. As a customer, like we should request how frequently we need to patch our Exadata box. Based upon that Oracle will patch. So sometimes Oracle will not patch, then customer has to do all this patching. So how about the next question comes, how about Cisco Switch and KVM and PDU? So these are the component rarely patched. So even we will patch this Cisco Switch, KVM and PDU, but it is not on quarterly basis or half yearly basis or yearly basis. This is we patched on demand, like whenever there is a issue or major release. So then Oracle will patch, or with the coordination with the Cisco Switch, customer can patch. So this is again a special category, so we will not consider for the any of the platinum patching. Okay, so this is about tools and patching components and all, but then comes to the next question, how frequently Oracle will release the patches? Oracle will release Exadata quarterly patches, QFSDP patches on every quarter, like quarter 1, 2, 3, 4, all 4 quarters they will release. So typically it will be Jan 18 or April 18 or July 18 or October 18. So these are the dates Oracle will typically releases the patches. So these are the two MOS document, 888828.1. This particular MOS document is for Exadata. It contains everything about all Exadata patches and all Exadata new release and patch history and what are the tools. Everything will be covered in this particular MOS document. And this is the remote deployment guidance. Like if you refer this 159445.1, this particular MOS document talks about how the remote patching works with Oracle. So please go through this document and refer it. It will be very good documents for understanding Exadata patching. So the QFSD patching limitations and considerations. So I just now told these are the components they will patch. So then how many components they will patch inside that? Like I have 8 DB nodes, I have 4 DB nodes, I have 2 DB nodes. Like how many patch, how many components, how many servers they will patch? So coming to that limitation and consideration, in the DB servers, again I said DB server patching is called M patching, and they will use a dbnodeupdate.sh script, and Oracle is supposed to patch all my DB nodes. And coming to the storage server, again cell patching they will call it as, and the patch mgr is a script they will use for patching, and Oracle is supposed to patch my all cell servers in my Exadata box. And coming to IB switch, they will call it as IB switch patching, and again they will use a patch mgr tool, patch mgr script, and Oracle is supposed to patch my all IB switches. So coming to the BP, where in traditionally we can call it as a PSU, and they will call it as a bundle patching. That is nothing but our normal traditional Opatch. So they will patch one grid home and 2 DB home per one Exadata box. If we have 4, 5, 6, 10 DB homes, Oracle will not patch. So they will patch only 2 Oracle home. Rest other DB homes should be patched by Oracle, patched by customer by themselves, or they need to talk to their patch coordinator and they need to talk to Oracle and get exceptional approval to patch extra Oracle homes, like 4 Oracle home or 5 Oracle home or 10 Oracle home. That has to be discussed with Oracle before in advance. They have to coordinate with their patch coordinator and then get exceptional approval to patch more Oracles than this 2 Oracle home. Default they will patch 2 Oracle home. Then how many databases they will patch? Databases is nothing but DB patching. They will run a cat bundle or data patch. Once you patch your DB home, you need to run a cat bundle at database level in case of 11.204, and you need to run the data patch in case of 12C onwards. So how many database they will patch? They will patch up to 40 database approximately, but the consideration is all these 40 database should run under any of these 2 Oracle home. If 10 database running on DBHome 1, 10 database running on DBHome 2, and 10 database running on DBHome 3, and 10 database running on DBHome 4, Oracle will patch only 20 database which are running on DBHome 1 and DBHome 2, which they have patched. And database running on DBHome 3 and 4, customer has to patch their Oracle binaries, and then they have to run this cat bundle or data patch on those 20 remaining database. So make sure that whatever database you are listing, those database should run only in the listed Oracle home. Otherwise Oracle will not patch. These are the considerations or limitations you should make sure. Or if you want to patch everything, you need to get an exceptional approval from Oracle before in advance. So if you see the typical architecture I showed here, the storage servers and up to 14 storage server, patch mgr they will use, and InfiniBand switch, 2 InfiniBand switches, the patch mgr again they will use for the IP switch patching, and DB server patching up to 8 database servers. This is a patch mgr. Again you can use a patch mgr bundle with dbnodeupdate.sh, or separately you can use dbnodeupdate.sh for this patching. Don't get confused with patch mgr. DB servers, database server patching will be done using dbnodeupdate.sh, or you can use a patchmgr and internally you can call your dbnodeupdate.sh for the db server patching. And coming to grid patching, they will use the Opatch, and coming to database home patching, they will use the Opatch. Again, I said here 1 db home gi home and 2 db home. And coming to the database patching, they will use cat bundle or database. This is same as our traditional cat bundle or data patch. There is nothing difference in the Exadata. So going to the next slide. What are the patching tools? I already explained. For the DB server, M patching, they will use a dbnodeupdate.sh shell script. Again, this shell script is written by Oracle, so you can find it in 888828 document. And for the storage server, they will call it as a shell patching. They will use a patchmgr shell script. Again, this is written by Oracle. Again, you can find this patchmgr script in 888828 one document. And for IB switch, again they will use a patchmgr shell script. So this is again shell script written by Oracle. So these are the same shell script. So this is for IB switch patching. And for the bundle patching, it is a normal traditional Opatch utility. And for the DB patching, catbundle.sql in case of 11G, and datapatch in case of 12C and mods. So the point here, CPU or PSU in traditional RDBMS, that has been replaced as a bundle patch in Exadata. They will call it as a bundle patch in Exadata. So dbnodeupdate.sh and db server patch.zip, and using this document you can get this dbnodeupdate.sh script, or you can go to 888828.1, that is the master document. You can find it everything in that document. These are the patching tools, I can say. And how the patching process works or takes place. The first point, you need to book a patching slot when you want your Exadata patching using a patching scheduling tool, or you need to request with your patch coordinator. There's a patch coordinator. Oracle person will be linked with every customer, so you can talk to that particular patch coordinator and then book your patching slot. That's a two-way you can do, either patching scheduling tool or patch coordinator. So now customer Oracle is strongly recommending us to use only this patching scheduling tool, and the scheduling the patching request by patch coordinator is very rare case. Always try to flexible, like try to expose yourself how to use this patching scheduling tool for the scheduling your patching request. And then once this scheduling if you book your patching slot using this patching scheduling tool, and there's a part, the automatic SR get created, and then to that SR you need to fill the patching template and upload it. Your patch coordinator will upload the template into your automatically created SR. You need to download that template and fill that template, and then with all the requirement, and upload it back to the SR. And then you need to run and upload Exacheck report to the same SR 4 weeks in advance. That that we can call it as a pre-Exacheck review. Oracle engineer will review that Exacheck report, and Oracle engineer will review your patching template, and then he will create a patch assessment 4 weeks in advance, and then upload it back to the SR. And then or again Oracle engineer will create a patch plan 2 weeks in advance and upload it back to the SR. So Oracle customer has to download this patch assessment and patch plan, and then make sure everything is ready, and then they have to review, and then they have to give sign off to the Oracle engineer. And then PPC patch pre-check will be done by 1 week in advance by the Oracle engineer. He will make sure that system is ready and we are good to go for a patching as scheduled, and then he will give a green signal for system side. If there are any critical issues, he will highlight, and customer has to take care of that. And then actually on the patching date, customer will release the system for the patching, and Oracle engineer will execute the patching all the steps, and then he will do entire Exadata box patching. And once the patching is done, customer has to run and upload post Exacheck report, and patch engineer will review it. Is there any critical issues after the patching? If there is no critical issue, and then Oracle engineer will give a sign off. And it is not necessarily customers to run and upload. If Oracle engineer has a root access on our system, he can run it by himself, and he will review it, and then he will give a sign off to the customers. This is a typically 8 steps, I can say. Each patching process or platinum patching process works, right? So going to the next slide. So the patching method, what are the patching method offered by Oracle, or a customer can choose? Customer can choose either rolling or non-rolling or hybrid. Rolling means patch one node at a time. If I have 3 DB nodes, I can patch DB node 1, DB node 2, DB node 3, one at a time. And if it is a non-rolling, I can shut down all my cluster DBs and all DB nodes, and I can start all patching on all three DB nodes at the same time. Similarly, bundle patching, GI patching and DB home patching, again shut down all my DBs and GI home, GI cluster on all DB nodes, and then start all together. Or you can start one node at a time. So that is a rolling and non-rolling. And storage server also, you can start a cell patching all cell nodes one by one at a time, or you can start all the 5 cells at same time. This is just a rough number I gave. You can do, a customer can have 3 cell nodes or 7 cell node or 14 cell node, whatever it is. Just I gave for example here. And IB switch, you can always, IB switch, make sure IB switch will be always rolling. IB switch cannot be done non-rolling. Cannot patch to IB switch at the same time. You have to patch IB switch one at a time. It always IB switch will be in rolling. IB switch, there is no non-rolling concept. If you can do it, you can lose the connectivity of your entire cluster, entire Exadata box. So coming to the hybrid, like you can make DB node patching as a rolling and cell patching as a non-rolling, or you can patch 1 and 2 together and 3 you can patch separately, or you can patch 3 cells together and then 4 5 you can patch it separately one by one. So hybrid is like mixed match, like you can do some part rolling and some part non-rolling. Anything you can choose for the patching method, right? So this is a type of patching methods you can offer. And coming to the Exadata rack size, so usually we used to say that mine is 1/8 rack or quarter rack or half rack or full rack. So customer can initially buy 1/8 rack, and then if their data grows, they can uh, migrate to a quarter rack. They can expand their 1/8 rack to a quarter rack, and if again data grows, they can again expand to half rack. And if that's a half rack and again data grows, you can over the future you can expand it to full rack. It is a online, you can don't need of any downtime. It can be done expand your rack whenever you need it. And you can decrease also if you don't want to go for full rack. Now you are in full rack, if you are not using efficiently full rack, and then you can decrease your rack by reducing some nodes. So that's also possible. So expand or decrease or increase dynamically, scalability, right? So coming to the eighth node or quarter node, quarter rack or eighth rack. So here D stands for DB nodes or DB servers, C stands for cell server, and I stands for IB switches. D, like how many DB nodes I can have? 2 DB nodes. In eighth quarter rack I have 2 DB nodes, and the cell nodes I have 3 cell nodes each, and IB switches I have 2 IB switches each. And coming to the half rack and full rack, I have a DB node, 4 DB nodes, and have 7 cell nodes and 2 or 3 IB switches. Coming to the full, I can have 8 DB nodes or 14 cell nodes, or I can have IB switches 2 or 3. So this is a typical combination in case of X8 8. This is the latest version X8. I'm talking about X8. 8 stands for X8-8. This 8 stands for 8 socket. And coming to the another way of configuration, it is X822. This 2 stands for 2 sockets. So if you see here, half rack or full rack, DB node always stands for only 2 DB nodes. I have only 2 sockets, right? If you see quarter rack or 8 rack, it is going to be same in case of 8 socket or 2 socket. The 8th rack and quarter rack are going to be same, like a 3 2 3. So 2 3 2 and 2 3 2 and 2 3 2 2 3 2. And coming to the half rack, again it is the difference is DB node I can see 4 here in 8 socket, and in 2 socket I can see DB node is 2. Coming to the full rack, in the 8 socket I can see DB node as a 8, and in a 2 socket I can say DB node as a 2. So only the 8 socket and 2 socket difference is the DB node changes. Rest other things are same, like IB switch and compute nodes. So IB switch and storage servers are going to be same. Only the difference in my compute nodes. I'll be having 2 DB nodes and multiple CPUs or multiple processors, like depends, like 2 socket and 8 socket. That's the difference here in compared with half rack and full rack in case of 8 socket and 2 sockets. Then if you see here like the history of Exadata box, starting with the V1 V2, and they started with the X series. x2, x3, x4, x5, x6, x7 and x8 is the latest one. And again you can see 2 socket will always stands for 2 and 8 socket always ends with 8. If you see here, x2 8, x3 8, x4 8, x5 8, x6 8 and x7 8. So this is x7 8 and x7 2. This is a 2 socket and it 8 socket. That's the only difference, the number of DB nodes. Other than that, all the sizes, all the storage, all the IB switches, everything is going to be same in case of 8 socket or 2 socket. So that's it guys. I hope that is this today's session is pretty informative, and always comment me if you have any concerns or questions. Always comment me on my YouTube. Thank you guys.